So next is type 2 integral, that is integral minus infinity infinity f of x dx. Type 1 was f of sin theta cos theta, it is minus infinity infinity f of x dx, where this function f of x is a fraction with numerator as g of x and denominator as h of x. These are two polynomials with degree of the denominator minus degree of the numerator is greater than or equal to 2. That is, degree of the denominator is at least 2 greater than that of the numerator. So in this case, consider this curve, a curve gamma which consists of a real line minus r to r, a real line, and this upper semicircle C. Okay, this is the part of a circle. So consider the curve gamma, minus r to r the real line and upper circle, and its circle is, its radius is r, so mod z is equal to r. So then this total integration over this gamma, curve gamma, is integral over gamma f of z dz is, this is the path integration, so along the real line and the upper semicircle. So integral minus r to r f of x dx, since it is in the real line, it is f of x dx. Then along the curve upper semicircle, that is integral over c f of z dz. And what about this integral over c f of z dz? It is, since this is the function, f of x is a function as a quotient g of x by h of x with degree of g of x minus h of x minus degree of g of x is greater than or equal to 2. So always the denominator has the has a degree which is at least more than 2 from the numerator, that of the numerator. So as r tends to infinity, that is the radius becomes infinity, this integration will be tending to 0 because the degree of the denominator is greater than that of the numerator by at least 2. So always if r tends to infinity, it tends cancelled and it becomes 0. So what is this integral over gamma f of z dz? It is the real integral minus r to r f of x dx. Okay. So applying this one, prove that integral minus infinity 1 by 1 plus x square dx is pi. So same curve gamma with first one along the real line minus r to r, then along the upper semicircle mod z is equal to r. So here integral minus infinity 1 by 1 plus x square dx is integral over gamma. Using the result 1 by simply convert the variable x to z, so 1 by 1 plus z square dz. And what about this singular points? 1 plus z square is equal to 0 implies z square is minus 1 or z is plus or minus I. So I means this is I is along the real imaginary axis. X axis is the real axis and y axis is the imaginary axis. So plus I is upper part of the imaginary axis and minus I lies the negative side. Okay. So since we consider only the upper semicircle, minus I is always, minus values are always lying outside C. Okay. So z is equal to plus or minus I, z is equal to plus I lies inside C and minus I outside C because it is along the lower part. So residue at z is equal to I f of z. It is limit z tends to I, z minus I into 1 by the function 1 plus z square. So it is limit z tends to I, z minus I into 1 by z plus I into z minus I cancels. So substituting the limit z tends to I, so it is 1 by 2I. So what is this integral? Integral over gamma is 2 pi I into, by residue theorem, sum of the residues. Since there is only one residue, it is 1 by 2I, so it is pi. Okay. That means the integral minus infinity 1 by 1 plus x square dx is pi.